This is the intro video for Calculus BC, and we're going to be looking at alternating series and the alternating series test. So up to this point, the only kind of series that we have looked at are series that have only positive terms. And so starting with this section, we're going to be looking at series that might have some negative terms. So the first type of that series we're going to look at is called an alternating series. And an alternating series simply is a series whose terms alternate signs. So plus minus, or minus plus, minus plus, minus plus, something like that. So I thought I'd use the calculator to help illustrate that. So notice here that I've set up a sequence in which we start with 1, and the pattern is going to be 1 over n. So I'll hit graph right here, and we'll be able to see, of course, that this series, we've talked about this series before. This, of course, we call the harmonic series. And so the terms start here at 1, and then 1/2, 1/3, 1/4, so on and so forth. So this would not be an example of an alternating series. This is an example of a series we have already seen. So I'm gonna take this now and I'm gonna turn it into an alternating series. And the way that I do that is this. I'm going to type in -1 to the n, and then I'll multiply that by the series that I had just a second ago, 1 over n. So of course, the 1 over n over here is, like I said, is exactly the same as what we had on the previous one, but then this -1 to the n, if you think about it, if n is going to go from 1 to 2 to 3 to 4 to 5, so on and so forth, then that -1 to the n is going to go from negative to positive to negative to positive, so on and so forth. So let's see what this looks like on a graph. So if I hit graph here, you can see how this works. You can see how the series look pretty similar in pattern to what we just saw with the harmonic series. But now, because of that alternating element, the series are going to switch signs or alternate sides of the x-axis for each term, right? We're going back and forth, and you can see that alternating pattern. So this is actually going to be a pretty helpful thing as far as convergence. Remember, we're kind of cheering for these series to converge. So if you think back to the harmonic series, the harmonic series always diverges, and we talked a little bit about why that is. Harmonic series diverges essentially because the terms, although they do approach 0, they approach 0 too slowly. It's close, of course, but they approach 0 too slowly to get a converging series. We're going to find out here in a little bit that an alternating harmonic series converges. And that's because the alternating signs nature of an alternating series actually helps kind of speed up the converging process. So for example, if we looked at some partial sums, like if I said partial sum based on the first two terms, that would equal -1 plus 1/2. That would equal, of course, -1/2. If I looked at maybe S4, that would be -1 plus 1/2 minus 1/4 minus 1/3 plus 1/4. And you can see maybe how the fact that these signs alternate from negative to positive are going to actually make the partial sum approach 0 faster than if the signs didn't alternate. This would end up equaling -1/2 equals what, -7/12, I think it would be. And so the negative and positive alternations are going to cause the series to converge down towards 0 faster than if those negative, positive alternating terms weren't there. So we'll look at this in a little bit more detail here in just a second. So as I said, the alternating element, the plus minus, are going to make it a lot easier for these series to converge. So here is your alternating series test. So if we just consider the terms to be positive, so in other words, if we kind of separate the terms from their alternating elements, and we have either one of these two series, so this would be the formula that gives the numeric value of the term, and so would this here, and this here, those would be the alternating elements. So those are the parts of the series pattern that cause the signs to alternate. So either one of these series, being alternating series, they will converge if the following two conditions are met. So the limit as n goes towards infinity of a sub n equals 0. So that just means that the terms are heading towards 0, and for every term, the n plus 1 term is less than or equal to the nth term. So in other words, as you progress from one term to the next, you see a pattern in which the terms are either equal or decreasing. And so you can kind of conceptually sum up these two conditions by saying we're thinking about the terms decreasing in absolute value to 0. Absolute value is a reference to the fact that we're just, of course, these are alternating series, but all we're doing is we're looking for the part of the series that is either approaching, decreasing towards 0 or not. And then, of course, we're looking for these a sub n's to head towards 0. So let's see here. The one example we're going to work here is this one right here, number 1. So the first thing we would recognize for number 1 here is that it is an alternating series. So I'm just going to put that right here. I'm going to say is an alternating series. And I'm going to say that the limit as n approaches infinity of 1 over n. So notice I'm ignoring the alternating element, which is right here. All I'm saying is that, hey, as I look at the 1 over n as n goes towards infinity, that's heading towards 0. And I want to recognize that a sub n plus 1 will actually be less than, it'll just be less than, but I'll put less than or equal to meet the condition, a sub n for all n. And all you really have to do there is, I mean, there's a number of ways you could prove that. All we really have to do here is just recognize it and state it. So because the terms are decreasing in absolute value towards 0, we can say that the alternating series converges. We'd say, therefore, you could just say the series converges, and I would put AST for alternating series test. Okay, so when you come to class, we'll look at some other alternating series, and later on the alternating series error bound, but that'll be a topic for another time. So for now, hope this went well. I'll see you in class.